Alright, so let's consider the question on the board. The question says a 200 newtons block rests on a wedge and on a ruler along the vertical wall as shown. If the weight of the block is twice force P, if the weight of the block is twice force P and the coefficient of static friction is the same at both surfaces of the wedge, and the coefficient of static friction is the same at both surfaces of the wedge, the question says determine the value of mu x, which is the coefficient of static friction, and the reaction on the wall and the reaction on the wall, neglecting the weight of the wedge and the friction between the vertical wall and block. Alright, so the first condition given to us is that the weight of the block is 2 times force P, and of course weight of block WP is simply 2 times force P. This is the wedge and this is the block itself, and the weight of the block is given here as 200 newtons. This simply implies that 200 newtons is actually equal to 2 times force P. Therefore, we make P subject of the formula, and this simply means that P is equal to 200 all over 2, which implies that the value of this force P is actually 100 newtons. So this is the first thing to do, find the value of force P. The next thing to do is you now start your analysis. You have a friction, you have a wedge and a load inclined on top of the wedge. So we start our analysis. First, you can choose to start with the load, or you can choose to start with the wedge itself. Okay, so we start by analyzing first the free body diagram of the wedge. Let's start with the wedge. FBD of wedge. We analyze the free body diagram of the wedge. And for the wedge, we simply have, okay, this, and this. And we have the force P, and this force has been found. The value of P is 100 newtons, so simply put down there 100 newtons. The angle of the wedge is simply 15 degrees. We have here 15 degrees. Okay. Now, this load, this 100 degrees load, pulls this wedge to move in this direction. This 100 degrees load pulls this wedge to move to the right, or to the right, as in this direction. Which means, if this load is moving in this direction, remember, this wedge is actually resting on a surface. Since the wedge is resting on the surface, once two surfaces are in contact, the first thing, or there is a must, whenever two surfaces are in contact, we always have what is called what? A normal reaction. First of all, friction must take place. But when two surfaces are in contact with one another, there is what is called a normal reaction. Normal simply means it is always what? At 90 degrees to the surface. So we have that this surface, this wedge is resting on the surface. Due to this contact, we have a normal reaction. Call that normal reaction N1. Okay, and it must be at 90 degrees to the surface in contact. So that's why it's called a normal reaction. Similarly, this wedge is also in contact with the block at this surface. The surface of the wedge is also in contact with the surface of the block. So which means we also have another normal reaction at that surface. There is bound to be a normal reaction whenever two surfaces come in contact with one another. We have another normal reaction here. Simply call this. Remember, normal reaction, it must always be at 90 degrees to the surface. So this is at 90 degrees to the surface. It must always be at 90 degrees to the surface, as can be seen here. This is at 90 degrees to the surface. So we call this simply N2, which is second normal reaction. Now, we apply this load P on the wedge, and this load pushes this wedge to move to the right. And frictional force is always what? An opposing force. If I'm moving forward, there's a frictional force that tends to what? Pull me backwards. So which means if this wedge is pulled or compared to move to the right, that means frictional force will act where? To the left. Is that also? And since this surface is in contact with this surface, if I'm pulling this wedge to move to the right, that means we are going to have frictional force acting against the motion to the left. So we'll have frictional force here against this motion. Call this F1. Since here is M1, call this frictional force F1. It doesn't also end there. We have these two surfaces in contact. That means there's also motion along this incline of the wedge. There's also motion along this incline. So if this load or this 100 meters load pulls this wedge to move to the left, to the right, it means frictional force will also act where? Up the plane. Because motion on this plane is acting where? Down. Is that clear? Therefore, frictional force will pull that motion up the plane. So we simply have a frictional force which opposes the motion up the plane. Call this F2. Okay, so this becomes your free body diagram. So all we need to do now is we have 100 inches purely horizontal. We have M1 purely vertical, we have this F1 purely horizontal, but we have just these two forces to be inclined. So what we'll do is simply resolve these two forces that are inclined, resolve them into what? Purely horizontal and purely vertical forces. Let's see the analysis now and see. Now, I will pick up this motion here. I have my normal reaction, N2. Yes? Yes.
We are pushing the block this way. If you we are pushing the wedge.
Yes.
The block is carrying up.
We are not on the block, it is free body diagram of wedge. Okay, so we have our normal reaction N2, we have the frictional force F2, they are at 90 degrees to one another, F2. So all I need to do is drop an imaginary line, one vertically and of course horizontally. So this is simply my y-axis and this is my x-axis. I have this. This is the frictional force and this is normal reaction, not for x. Now, the angle which the normal reaction makes with the vertical line, always keep that in mind. The angle which the normal reaction makes with the vertical line is simply called what? Angle of inclination. The angle which the normal reaction makes with any vertical line, not just the weight, but any vertical line at all, is simply called the angle of inclination. And the angle of inclination here is 15 degrees. I have a vertical line here, I have this normal reaction here. It means the angle between them is simply 15 degrees. And of course, if here is 15 degrees, it means here will be what? 75 degrees. Because 90 minus 15 will give us 75. Yes. The angle which the normal reaction makes with any vertical line is the angle of inclination. Any vertical line. And this is normal reaction, N2. This is a normal reaction. This is the vertical line. The angle between them is the angle of inclination, 15 degrees. You have this. If here is 15, of course, here is 75. 90 minus 15 will give us 75. And you have that. Okay, let me extend this N2 a bit. This is N2. So, just like in what I explained, the angle between the normal reaction and the vertical line, this is the vertical line as well. This is normal reaction. So, you also have here to be 15 degrees. And if here is 15, of course, here is also 75 degrees. Okay, also the angle which the frictional force makes with the horizontal line, the angle which the frictional force makes with the horizontal line is also the angle of inclination. The angle which the frictional force makes with the horizontal line is also the angle of inclination. And I have my frictional force here. This is the horizontal line. With this angle here is also what? 15 degrees. This is also the frictional force. This is the reaction, that means here is also 15 degrees. So here becomes 75 and here becomes 75. You have this. So all we need to do now is resolve the frictional force and normal reaction into vertical and what? Horizontal components. To do this is simple. To resolve the normal reaction here into vertical component, you hold the tip of the angle, pull this force till it meets vertical line. If you pull this force to meet vertical line, where will the direction of this arrow point? Downwards. So you simply have this normal reaction pointing downwards. and this force passes through this angle 15 degrees. And I said, whenever a force passes through an angle to any component, what do you do? Multiply by what? Cosine of the angle, right? Okay, so we simply have this is what? N2 multiplied by cos 15. This becomes the vertical component of this force. Next is to resolve this force horizontally. Since the force is two-dimensional, we don't just resolve vertically, we also resolve horizontally. Resolving this force horizontally, go to the tip of the arrow of the force, pull this force to meet the horizontal line, which is the x-axis. This is the x-axis. If you pull this force to meet the x-line, where will this force point? Negative to the left, right? This force points to the left, so you can near that there. It points to the left. And it passes through which angle? 75. So it becomes N2 cos 75. Always multiply by cosine of the angle it passes through to get the what? Given axis. Next, we resolve the frictional force into vertical and horizontal components. I want to resolve the frictional force in the vertical axis. I'll hold this for the arrow of the force. Pull this force to the vertical line. Which direction does this force point? Positive. Positive. It points upward, right? So I have this force pointing upward. Okay, let me do that on here. I have this frictional force pointing upwards. And it passes through which angle? 75. So it becomes F2 cos 75. I also want to resolve this force horizontally. Hold the tip of the arrow, pull the force to meet the x line. Which angle does it pass through? 15 degrees. And what direction does it point? Negative to the left. So I'll simply have this force pointing to the left. The value remains F2 cos 15 degrees. So that is all you need to do. Resolve these forces, these inclined forces, into purely horizontal and purely vertical. Once you're done, you simply employ the equilibrium equation. So everything in friction and wedge, in fact everything on applied mechanics, all of them settles down towards two-dimensional force. That's all. Apart from 3D, every other thing in applied mechanics is simply two-dimensional. Okay, so we employ the equilibrium equation. Let me start that over here. We employ the equilibrium equation. Summation f of x is equal to what? 0. We consider, now take note, in friction, you don't just consider force that points to the left to be negative and force that points to the right to be positive. No. In friction, motion about or force that points in the direction of motion is what we consider as what? Positive. So if friction, or if, let me say, a force is pushing an object to the left, that means every force that points to the left will become what? Positive. Okay? Because frictional force will act what? Opposite. So always keep it in mind, always the value of every frictional force must always be what? Negative. Always. It must always be negative. Okay, so summation of force in the x-axis is simply equal to 0. Now, remember that this motion is inclined. Is that also F2 is inclined? And now resolve this force purely horizontal. That means this force will point to the left. Is that also? Which means motion to the left should be what? Negative. Is that okay? Okay then. Let's see. So motion to the left is negative because frictional force is simply what? And you can see it here, frictional force F1 is pointing to the left. So motion to the left becomes negative. Motion to the left of this one becomes negative. That means motion is positive here to the right because of this load applied. This load is pushing this object to the right. Is that okay? Yes. So summation of f of x is simply 0. We consider force that point to the right to be positive since motion is to the right, and force that point to the left to be negative. And if we do that, on this system, which is the wedge now, I have F1 pointing to the left. That's simply what? Negative. So minus F1. I have 100 newtons pointing to the right, which is what? Positive. Plus 100. I also have N2 cos 75 pointing to the left. That's negative. Minus N2 cos 75. I also have F2 cos 15 pointing to the left, which is negative, minus F2 cos 15. I think these are the only horizontal force we have. Yeah, that's all. So the whole of this is equal to 0. You keep this aside. So give me Take note, please. Okay, so give me cos 75. This is now minus f1 plus 100 minus n2. Please give me cos 75 in two decimal places. 0.26 n2. Okay, minus cos 15. 0.97 f2 equals 0. Okay, so but recall, let's continue that here. Recall that f1 is actually mu1 times n1, not forgetting where mu is the coefficient of static friction, and also f2 is equal to mu2 times n2, where mu is also coefficient of static friction. And the question says if the coefficient of static friction at all surfaces are what? The same. From the question you can check if the coefficient of static friction at all surfaces are the same, which means and the value is being signified as mu x. So this simply means that this implies that mu1 is equal to mu2 and simply equal to what? Mu x. The coefficient of static friction at all surfaces are the same. It doesn't change. It remains the same. So this now means that f1, this now implies that f1 will simply becomes mu x times n1, and also f2 will become mu x times n2. You have this. So if you have this, we can now substitute into this equation in place of f1 and in place of f2. We are simply going to have for f1, it becomes minus mu, minus mu x times n1 plus 100 plus 0.26 n2, minus 0.26 n2 minus 0.97 mu x n2, 0.97 mu x n2 in place of f2 there, and this is equal to 0. So let's see if we can collect if anything is common. I have n2 here, I have n2 here, or you can still keep this aside. Call this equation 1. Call that equation 1. Next equilibrium law, summation of vertical forces is equal to 0. Now, motion is neither up the plane or down the plane, so the rule of vertical forces must always be obeyed in friction. Since motion is not vertical or downward, it simply means that the rule of vertical force must be obeyed. Summation of y equals 0. All force that point vertically upward should be positive, while downward should be what? Negative. This must be obeyed. So we assess the beam again, we assess the wedge again. I have n1 pointing upwards on this wedge, so it's positive. You put it down, n1. I also have f2 cos 75 pointing upward, so it's positive, plus f2 cos 75 plus f2 cos 75. I also have n2 cos 15 pointing downward, so it's negative, minus n2 cos 15 minus n2 cos 15, and the root of this is equal to 0. Not forgetting that f2, recall that f2 itself remains mu x instead of mu2 because the coefficient of static friction at all surfaces are the same, so it becomes mu x times n2. So in place of this f2, I will simply have n1 plus, please, cos 75 is 0.97, right? Yeah. Or 0.26. Cos 75. 0.26. So I will simply have 0.26 in place of f2. F2 becomes mu x n2 minus cos 15 gives us 0.97 2. The whole of this is equal to 0. So, of course, I have here n2 and n2, which means I can actually make n1 subject to the formula. So, for n1, simply send every other term over to this side. n1 becomes send minus 0.97 n2 over here. Negative sign plus at the box sign becomes positive. I have 0.97 n2, okay, plus 0.26 mu x n2 plus side becomes minus 0.26 mu x n2. So call this equation 2. Notice now that I can substitute in place of n1 in equation 1. I can put in the value of equation 2 into equation 1 and make everything on this equation all in terms of what? N2. Is that not so? Okay, so simply what? Substitute equation 2 into equation 1. Substitute equation 2. Are you guys feeling at all?
Yes.
Okay, into equation 1. Okay, so substitute 2 into equation 1. We are simply going to have mu x minus mu x in place of n1. n1 is simply 0.97 n2. So I have 0.97 n2 minus 0.26 mu x n2 minus 0.26 mu x n2, okay, minus 0.26 n2 minus 0.26 n2 minus 0.97 mu x n2, then plus 100. There's 100 there, so simply plus 100, and it is equal to 0. So we may wish now to expand the bracket. Minus mu x multiplied 0.97 will give us minus 0.97 mu x n2. Minus times minus is plus, so I'll simply have plus 0.26. Okay, this is mu x times mu x gives us mu x all squared n2, okay, minus 0.26 n2 minus 0.97 mu x n2 plus 100 equals 0. So I think here something can go. I have minus 0.97 mu x n2 minus 0.97 mu x n2. So these two can add. So you give me minus 0.97 minus 0.97. That gives us minus 1.94 mu x n2 plus 0.26 mu x squared mu x all squared n2 minus 0.26 n2 minus, okay, plus 100 plus 100 equals 0. At this point, n2 is common in all. Let's factor n2. n2 is common in all. Let's factor n2. I will simply have minus 1.94 mu x plus 0.26 mu x all squared minus 0.26 all into n2 plus 100 equals 0. So I can send 100 over to this side of the equation. I will simply have minus 1.94 mu x plus 0.26 mu x squared minus 0.26 into n2, and this is equal to minus 100. Positive 100 plus an equal sign becomes negative 100. Therefore, let's make n2 subject. This now implies that n2 itself is now equal to minus 100 divided by the root of this value. minus 1.94 mu x plus 0.26 mu x squared minus 0.26. You can call this equation 3, right? Call that equation 3. So we keep equation 3 aside for n2. We keep equation 3 aside for n2. So we are done with the analysis of the wedge. Let's now move to analyze the block. That's the next thing to do. We move now to analyze the block. Okay, so we simply consider the free body diagram of the block. So we consider FBD, free body diagram of block. Free body diagram of block. So let's pull out the block. We simply have this, and of course this. And on this side of the block or the vertical wall, we have a roller support. And for a roller support, we have just one reaction. That reaction is always what? Normal to the surface, which is at 90 degrees. So we simply have a normal reaction here at 90 degrees to the water roller support there. Call this N3. Since we already have N1 and N2, call that reaction N3. Also, the block has a weight of 200 newtons vertically downwards. You indicate the weight of the block vertically downwards, value is 200 newtons. Now, this block is also in contact with the wedge. The block is in contact with the wedge, and whenever two surfaces are in contact, what do you have? You have a normal reaction. And that normal reaction must be what? At 90 degrees to the surface. But in this case now, it is still the same normal reaction that is governing what? The block and the wedge. Still the surfaces are in contact. So it is still the same normal reaction governing the wedge that governs the block. And that normal reaction is simply N2. So we still have N2 at 90 degrees to the surface. So it must always act at 90 degrees to the surface. This is simply N2. They must be at 90 degrees to the surface, as can be seen. At 90 degrees to the surface. Now, take note. If this load or this force compels the wedge to move to the right, it means that this block will exert a motion where? Up the plane. Is that also? The block will exert a motion up the plane. So if the block is moving up the plane, on this block, it means that the motion of this block is where? Up the plane. Where will frictional force act on the block now? Down. So you have frictional force acting down against opposing that motion. Since this wedge is the block is moving up the plane, we will simply have frictional force down the plane, F2. It is still the same frictional force acting on this surface, but now in the opposite direction due to the motion of this block. So we'll call that F2. Okay, so I think that is all for the block. There is no other force or any other analysis for the block. This is all. So all we need to do is the wave is having a purely vertical force. I will have to have a purely horizontal force, but we have these two forces to what? Inclined. So all we need to do is pull out these two forces that are inclined, resolve them into purely vertical and purely what? Horizontal components. So we pull out the normal reaction, which we have here, N2. We also have the frictional force, both of them are 90 degrees to one another, F2. You draw an imaginary line. An imaginary line. Draw an imaginary line. So this becomes your y-axis and this becomes your x-axis. So this shows now that the two forces are actually what? Inclined. Let me extend N2 a bit. Okay, let me extend N2 a bit. So N2. Now I said the angle between the normal reaction and the vertical line is what angle? Beautiful. So this is the vertical line, this is normal reaction. The angle between them is 15 degrees. The angle of reaction is 15. And if here is 15, it means this angle here is simply what? 75. Simply 90 minus 15. I also said that the angle between the frictional force and the horizontal line is also what? The angle of inclination. So we have here to be 15 degrees. This is the frictional force. Angle between frictional force and horizontal line is simply 15 degrees. We also have the frictional force, this horizontal line, here is also 15 degrees. So we have here to be 75. And of course, we have here to be 75. And this is the normal reaction. Angle between the normal reaction and the vertical line is 15. And we have here to be 75. Okay? So you have all that. So all we need to do now is resolve the normal reaction into purely vertical and purely horizontal forces. So to resolve this force vertically, to resolve N2 vertically, hold the tip of the arrow, pull the force to the mid vertical line. If you pull this force to the vertical line, what direction does this force point? Positive, you point upwards, and it passes through this angle, 15 degrees. You simply multiply by cosine of the angle it passes through. So I will do that resolution over here. If I pull this force to the vertical line, it points upwards. I will do it over here. And it passes through this angle 15 degrees. So you simply multiply N2 cos 15 degrees. Resolving this force horizontally, hold this force, I will pull the force to the horizontal line. Which direction does this arrow point? To the right. It points to the right. So you have this force pointing to the right horizontally. And it passes through what? This angle 75 degrees. So simply multiply by N2 cos 75. Multiply by cosine of the angle it passes through. So you have that sorted out. Next is to resolve the frictional force F2. If you resolve this force vertically, hold the tip of the arrow of the force, pull the force to the vertical line. Which direction does this force point? You pull this force to the vertical line, this force points downwards. And it passes through this angle 75 degrees. So you simply multiply F2 by cosine of the angle it passes through, that's called 75. Resolving this force horizontally, you hold the tip of the arrow of the force, pull the force to the horizontal line. Which direction does this force point? Positive to the right. It points to the right. So you have it here, pointing to the right. And which angle it passes through? 15. So you simply multiply by cosine to F2 cos 15. That's all. This becomes the analysis of the wedge of the block. So we simply apply what F the block equation to it. Okay, so I think I can write here now. Alright, so we apply the equation summation f of x is equal to 0. And remember, the motion of the block, the motion of this block is simply what? Up the plane, not forgetting. The motion of the block is up the incline. And remember, up the incline is simply like this, up the plane. And we resolve this to be purely horizontal. That's pointing now to the left, purely horizontal. So it means that for the block, motion to the left will be what? Positive. Keep that in mind. For the block, motion to the left will be positive. So that simply means force that point to the left should be what? Positive, while force that point to the right should be negative. Whichever way, frictional force must always be negative in the direction of motion. Alright, so if we do that now, I have N3 pointing to the left. So which means N3 is positive. It is pointing to the left. So you put it down, N3. I also have N2 cos 75 pointing to the right, so it's negative. N2 cos 75 to the right, so it's negative. Minus N2 cos 75. I have F2 cos 75 also pointing to the right. Sorry, F2 cos 15 pointing to the right, so it's negative. So you will see that the frictional force is negative. F2 cos 75 cos 15 pointing to the right, so it's negative. Minus F2 cos 15. Okay. I think that's all. Yes, that's all the horizontal components. So the whole of this is equal to 0. So this becomes N3 minus cos 75 gave us 0.26. We have 0.26 N2 minus cos 15 gave us 0.97 F2, and this is equal to 0. Not forgetting, F2 is simply mu x N2. So this simply implies that N3 0.26 n2 minus, it becomes 0.97. In place of f2, we simply have mu x n2, and this is equal to 0. Well, you can make n the subject. N3 is equal to, send everything over to this side of the equation. I will simply have negative 0.26 n2 cross over the positive. I have 0.26 n2. Okay, minus 0.97 cross over become positive plus 0.97 mu x n2. Call this equation 4. Call that equation 4. You employ the next equilibrium law. Summation of vertical forces, summation f of y is equal to 0. Since motion is neither in vertical direction, you simply consider upward force to have positive momentum force, and downward force will be what? Negative. So if you do that, I have 200 newtons acting downwards on this block, so it becomes minus 200. I also have F2 cos 75 acting downward, so it's negative, minus F2 cos 75. I also have N2 cos 15 pointing upwards, so it's positive, plus N2 cos 15. The whole of this is equal to 0. So this gives us minus 200 minus, in place of F2, of course, cos 75 is 0.26, and F2 itself from here is mu x n2, so it becomes 0.26 mu x n2 minus, this one plus, cos 15 is 0.97, so it becomes 0.97 n2, and this is equal to 0. So from here now, let's send minus 200 over to this side of the equation and factor n2, because n2 is common here. So we simply send minus 200 over here. So if we send minus 200 over here, it becomes positive. I am left here now with minus 0.26 mu x. We are trying to factor n2 now, so keep n2 aside, plus 0.97 all multiplying by n2, and this is equal to, send minus 200 over here, it becomes 200. Call this equation 5. So we can make n2 subject from equation 5, or without calling that equation 5. Let's simply, okay, so without calling this 5, let's simply make n2 subject formula from here. Let's make n2 subject from here. We can do it over here. Make n2 subject formula from here. You are simply going to have that n2 is equal to, it becomes 200 divided by the whole of this value. You simply have 200 all over the whole of this value is minus 0.26 mu x plus 0.97. Call this equation 5. So notice now that equation 5 and equation 3 are the same. 5 and 3 are the same. Two of them are the same, values for n2 and values for n2, so we can equate 5 and 3. Two of them are the same. So equating 5 and 3. So we simply equating 5 and 3. Equating 5 and 3. So we simply have in equation 5, we have 200 all over 0 minus 0.26 mu x minus 0.26 mu x plus 0.97, and that's equal to minus 100 in equation 3 all over minus 1.94 mu x plus 0.26 mu x squared minus 1.94 mu x plus 0.26 mu x squared minus 0.26 minus 0.26 minus 0.26. So from here now, well, you can simply cross multiply. Let everything here multiply this top, and let everything here multiply this top. So if you cross multiply, you simply have here 200 multiplying everything down here minus 1.94 mu x plus 0.26 mu x squared minus 0.26, and that is equal to everything here multiplied by 100. I'll have minus 100 into minus 0.26 mu x plus 0.97. So from here, what I will do to make it easier, instead of expanding the bracket by 100 or by 200, I will simply say divide through by 100, so that the bracket becomes doesn't look too big. Divide through by 100. If I divide through by 100, I will simply have 200 divided by 100. That will give me 2. 200 divided by 100 will give me 2. So I'll simply have 2 into the whole of this bracket minus 1.94 mu x plus 0.26 mu x squared minus 0.26, and this is equal to minus 100 divided by 100 becomes 1 minus 1. So I will simply have minus into minus 0.26 mu x plus 0.97. So I simply have this. So I will have 2 multiply the whole of this bracket. 2 times minus 1.94 give me 2 times minus 1.94.
3 points
minus 3.88 mu x plus 2 times 0.26 0.52 mu x all squared minus 0.52, and that's equal to minus times minus 0.26 simply gives us plus 0.26 mu x minus times plus 0.97 will give us minus 0.97. So I have this. So all I need to do at this point is simply what? Collect like terms. Collect like terms.
That's in the last part.
So you simply collect like terms. We simply collect like terms. So let's keep all the values here. Minus 3.88 meters. Okay, give me those values please. Minus 3.88 mu x plus 0.52 mu x squared minus 0.52. Okay, so we simply send plus 0.26 mu x over to this side of the equation. Positive sign plus and equal sign becomes negative, and here minus 0.97 cross sign becomes plus 0.97. So I'll simply have minus 0.26 mu x minus 0.26 mu x plus 0.97, and both of these is equal to 0. Okay, so I have minus 3.88 mu x minus 0.26 mu x. What was that value? Minus 3.88 mu x minus 0.26 mu x. Simply minus 3.88 minus 0.26. Minus 4.14 mu x. I also have here, okay, put down plus 0.52 mu x all squared. Then I have minus 0.52 plus 0.97. Minus 0.52 plus 0.97. What? 0.45. Okay, so plus 0.45. Both of this is equal to 0. So I can rearrange this equation now. Let it be of order squared and then 1 and then that. So we simply have rearranging, we have 0.52 mu x all squared minus 4.14 mu x plus 0.45 equals 0. And if you look at this simply becomes a quadratic equation. It becomes a quadratic equation. So we simply employ general formula. And from general formula, we have that mu x is simply minus b plus or minus the square root of b squared minus 4ac all over 2h. Where a is the coefficient of mu x squared, which is 0.52. 0.52. B is the coefficient of mu x, which is minus 4.14. Minus 4.14. And c is the constant term, which is here given as 0.45. 45. Therefore, mu x is now equal to minus b. You have minus, but b itself is minus 4.14. So minus 4.14 plus or minus square root of b squared, which is minus 4.14 all squared minus 4a. A is 0.52 or 0.52 multiplied by c is 0.45 all over 2 times a is 0.52. What's the problem now? I solved this question on my own exam. I don't know, these are the questions I like to solve, these ones that are long. And the ones I like to solve. I solved it on my own exam and I got the answers complete. I made it in applied very easy. Very easy. Okay, but let's fall back to I can work here now for this side is spacious. Okay, so mu x is now equal to, take note, minus 4.14 becomes positive. So I'll simply have 4.14 plus or minus square root. Please give me 4.14 squared. 17.14 minus 4ac, which is 4 times 0.52 times 0.45. It was 0.94 all over 2 times 0.52. That it was 1.04. Okay. So mu x is equal to, we have 4.14 plus or minus the square root of 17.14 minus 0.97. No. Is it 16.2 or 6.2? 17.14, 16.2 all over 1.04. Mu x equals 4.14 plus or minus the square root of 16.2, 4.02 all over 1.04. Therefore, mu x is equal to, we have 4.14, we're having plus or minus, so we're having two values. So we test first on the positive axis, plus 4.02 all over 1.04, or mu x will simply be 4.14 minus 4.02 all over 1.04. This means mu x is equal to 4.14 plus 4.02, 8.16. That was 8.16 all over 1.04, or mu x is simply 4.14 minus 4.02, 0.18, 0.12 all over 1.04. So it simply means that mu x is equal to 8.16 divided by 1.04, 7.85, or 0.12. And we know that the coefficient of friction can never be what? Greater than 1. The coefficient of friction can never in this life be greater than 1. So this simply implies that mu x is equal to 0.1. That is